In this video, I'll be going over the Chapter 4 homework problems. So in this first problem we're examining ATM service fees. Let's say an ATM with a service fee of $2 is used by a person 100 times in a year. What would be the future value in 10 years? Use a 3% rate of the annual amount paid in ATM fees. You'll be using Exhibit 1B for this problem. So we first need to find out what the annual fee is. So that's where we'll take the service fee of $2 right here and multiply it by the number of transactions per year, which is 100 times used. So taking 2 times 100, we get an annual fee of $200. Now, our tendency is to stop there. We think, okay, it costs me $200 a year to use the ATM. But it's also important to think about the future value. What if we weren't wasting our money on these annual fees and could put it towards something useful like investment or savings? So we're going to now have to calculate the future value of the annual fee we just determined and then multiply that by the future value factor from Exhibit 1B. So we're going to be using the 10 years and the 3%. So we learned about this back in Chapter 1. So this should be a refresher. So here we are on the left. So I'll go down the period until I get to 10 years. And then we'll look for the column that says 3% interest. So 1, 2, 3%. And then I'll go ahead and move down until I get to my 10-year row. So that means my future value factor is 11.464. So we'll take our annual fee of 200 times our factor, and our future value is $2,292.80. In our second problem, we're looking at payday loans. A payday loan company charges 5% interest for a 2-week period. What would be the annual interest rate from that company? Go ahead and assume an even 52 weeks per year, and you're going to enter your answer as a percent rounded to 1 decimal place. So here's our formula for the annual interest rate. We'll take the interest rate per period and we'll multiply it by the number of periods per year. So since we're assuming 52 weeks per year, and in the problem it states that the payday loan company uses a 2-week period, we'll take the 52 weeks divided by that 2-week period. So then we'll take our interest rate of 5% or 0.05 when we rewrite the percentage as a decimal number and multiply it by the 26 periods. When I multiply those two numbers on my calculator, I get 1.05 or 105% as the annual interest rate. So in this problem, we're going to be working with savings, specifically the time value of money. So again, we're going to use the content we learned back in Chapter 1 to determine the savings amount for each of the situations in parts A through C. So in Part A, what would be the value of a savings account started with $700, earning 4%, compounded annually after 10 years. So our formula for the future value, because we want to know what it's going to earn in the future after 10 years, it's the amount deposited times our future value factor. Since it's a single deposit, because it only mentions started with 700, and it makes no other mention of additional deposits, we assume one time. That means we're going to be using Exhibit 1A. So recall the different exhibits apply to different situations, and you have to understand which situation goes with which exhibit. So we're going to go ahead and look over at Exhibit 1A. So our period of time is 10 years, and our interest rate is 4%. So I'm going to go down the 4% column until I get to the 10-year row. So my factor is 1.48. So when we take our amount deposited originally, the $700, times the factor of 1.48, we'll get a future value of $1,036. Let's look at Part B. Brenda Young desires to have $15,000 8 years from now for her daughter's college fund. If she will earn 6% compounded annually on her money, what amount should she deposit now? So again, here we're looking for present value because she has a desired future amount. That's the amount desired right here. But she needs to know what she has to deposit today. And again, in our story here, it only mentions a single deposit. It doesn't talk about multiple deposits. That's how we know we're going to be using Exhibit 1C. So here's Exhibit 1C. And under the period, we're going to go down to the 8 years. So I always like to find the period first to make sure I know how far I'm going to be looking down. And for the percentage, we're looking for 6%. So I'm going to go across the top till I find my 6%, and then I'll go down until I find my 8 years row. So that's 0.627 for my factor. So we'll take our desired amount, the 15,000 that Brenda wants in 8 years, times the PV factor of 0.627, and put that in our calculator, and we get $9,405. So that's how much she needs to deposit today into her daughter's college fund in order to get $15,000 in 8 years. So in both of these examples, we were looking at a single deposit. So in part C, we're going to be finding what amount would you have if you deposited $1,800 a year for 30 years at 8% compounded annually. So you can see in this problem, we're going to be working with multiple deposits. In this case, $1,800 a year for 30 years. So that means we're going to be looking for the future value because we want to know what it's worth in 30 years. And we're going to be using Exhibit 1B because that's the one used for multiple deposits. So here's our Exhibit 1B, and I'm going to go down the period until I find 30 years. And then we're looking at 8%, so I'm going to find the column at 8%, and then I'll go down until I get to my 30-year row. And so the factor is 113.283. So taking our amount deposited of $1,800 a year times our future value factor of 113.283, we get a future value of $203,909. So you can see how important it is to take what we now learned about savings in Chapter 4 with the time value of money in Chapter 1 to really understand the impact of our savings. In this next problem, we're looking at the certificate of deposit in terms of penalties. A certificate of deposit will often result in a penalty for withdrawing funds before the maturity date. If the penalty involves 2 months of interest, what would be the amount of early withdrawal on a $20,000 5% CD? Here's the formula for the early withdrawal penalty. We're going to be taking the account value multiplied by the annual interest rate times the number of penalty months divided by 12. Because we know in a year there are 12 months and we have to account for the number of penalty months. So plugging in our numbers, our account value was the 20,000. Our interest rate, we're going to convert to a decimal number. Here's the 2 months that the penalty involves for early withdrawal, divided by the 12 months possible in a year. So when I plug all that into my calculator, we get $166.67 as my early withdrawal penalty. In this next problem, we're going to be looking at overdraft protection charges. Let's say a bank provides overdraft protection charges at 12% for each $100 or portion of $100 borrowed when an overdraft occurs. So in Part A, what amount of interest would the customer pay for a $188 overdraft? Assume the interest is for the full amount borrowed for the whole year. Here's the formula for the interest or the overdraft protection charge, and it equals the number of increments times the portion times the interest rate. So we have to look at how many increments we're working with in terms of the $188. Note that we're charged for each $100 or portion of 100. So if I look at this, there's a whole 100 in there. And then what I have left is the $88, which is still a portion of 100. So really I'm working with 2 increments. So the portion is the $100 according to the bank, and then our interest rate. So we'll take our 2 increments times 100 times our 12% interest, which we've converted to a decimal to 0.12. When I multiply that across, the interest or the charge for overdraft is $24. Let's go to Part B. How much would be saved by using the overdraft protection loan if a customer has 2 overdraft charges of $30 each during the year? So here's the formula to figure out how much we're saving. So we'll take the number of overdrafts, so here we're told that we have 2 of them, times the overdraft charge minus the protection fee. So the overdraft charge, this is the fixed charge that you could have as opposed to the protection fee based on an interest rate above that we worked with. So we'll take the 2 times the 30 and then subtract the $24 that we calculated in Part A. So we'll take our 2 overdrafts times the fixed fee of $30 for each overdraft, and then we'll subtract the protection fee. So this assumes that, hey, instead of paying the fixed fee each time we do an overdraft, we're just going to use the protection fee, which we already calculated in Part A. So I want to make sure 2 times 30, that gives me $60, and $60 minus 24 gives us a savings of $36. So by agreeing to use the overdraft protection charge at the interest rate of 12% with the bank, you actually save money as opposed to having a fixed overdraft charge of $30 for each time it occurs. So this is helpful to understand whether or not you should take the overdraft protection. So in this next problem, we're going to be looking at the net annual cost of checking accounts. So what would the net annual cost of the following checking accounts be? In Part A, we're given the monthly fee is $3.75. We've got a processing fee of 25 cents per check, and the number of checks written on average per month is 14. So here's our formula for the net annual cost. We're going to take 12, because there's 12 months in a year, times, and in the brackets here, what we're actually doing is figuring out the monthly cost. So for our monthly cost, it first takes into account the average number of checks per month times the cost per check, and then the monthly fee to have the account. So that's where we'll take our 14 checks per month times the 25 cents per check, and then our monthly fee is $3.75. So we'll multiply these two first, then add the $3.75, and then take that amount, that's our monthly costs, and then multiply it by the 12 months in a year, and our net annual cost then is $87. In Part B, the interest rate earnings of 4% with a $500 minimum balance. The average monthly balance is $600, so we can see, yep, we're doing a good job of achieving the minimum balance. We get a monthly service charge of $15 for falling below the minimum balance. So if we don't maintain that $500, we get charged $15 a month. And it turns out that occurred 3 times in a year. And note that when that happens, no interest is earned in these months. So we're actually calculating a couple of things, right? We're calculating the interest earnings, we're calculating the service charges. And so our net annual cost here is taking the service charge, so that's the $15 a month when we're below the minimum balance, and it happened 3 times. So that's 15 times 3 over here. And then for the interest earnings, we're told we'll earn 4%. That's right here. That's the 0.04. And we have an average monthly balance of $600. So that's why I'll take 600 times the 0.04. Then we have to multiply it by the number of months out of the year that we earned interest. So since we fell below the minimum balance 3 months in a year, and we know that there are 12 months in a year, we'll take 12 minus 3. That means I did earn 9 months out of the 12 months for interest. So that's where I'll also use my calculator, solve this part, then multiply it by the 9 out of the 12 months, and that'll give me my interest earned on the right. Then I'll subtract the service charge and the interest earnings from each other, and we get $27. So as you can see, there's a lot of pieces that we have to account for. So you want to be careful as you read through the problem that you don't miss any of the pieces. In this last problem, we're going to be working with bank reconciliation. So you're going to be given some information here, and you'll be asked to prepare a bank reconciliation to determine the adjusted or corrected balance. So in the homework, you'll see it as a chart with some boxes that you'll fill in the blank. But here we're just going to work it out in the different pieces to make sure we identify the correct number and what the final balance is for our bank statement and our checkbook. So for the adjusted bank statement, we'll take our bank balance plus the deposits in transit, that means the deposits coming in, minus the outstanding checks. So we'll take the $680 plus the $60 minus $112, and we get $628. In the next part, we have to find the adjusted checkbook balance. So we'll take the checkbook balance plus the interest earned plus our direct deposits minus our account fees and minus any ATM withdrawals. So plugging in all our numbers from the above, we get 642 plus 8 plus 70 minus 12 minus 80 for an adjusted checkbook balance of $628. You'll know that your numbers are right for your bank reconciliation if they match the bank statement to the checkbook balance. Now note that when you are filling this in the fill in the blanks on the homework, you'll want to enter in your answers as positive values because the formulas in that chart will subtract and add where it's supposed to. So if you have any questions, just let me know.